Hi students, this is Mr. Yang. Today we are going to talk about 4.19b, where we will learn to graph more piecewise functions. We're going to graph ones that actually involve quadratic functions, but the process is actually the same. So here's example 1. Let's look at the domain first. The first one is x is greater than or equal to 1. The second one is x is less than 1. That means I do have an endpoint at 1. I need to draw a line right here at x equals to 1. Now it's time to graph the line separately. The first one, 2x plus 1. Slope is 2 over 1, and intercept is 1. So up 2 over 1, up 2 over 1, up 2 over 1. And I can backtrace to the bottom. And that would give me a line right there. Next, I have x squared plus 3. If you think back about what we have learned, the a of x minus h to square plus k, that is the transformation we have learned. If we have this plus 3 on the end, that actually means moving up 3. So 1, 2, 3, that's my point. And 1 left, 1 up, 1 right, 1 up, 2 left, 4 up, and 2 right, 4 up. That's typically how the standard parabola looks like. I can finish graphing that. And now it's time to start erasing and see which part we're going to keep. For the linear one, x is greater than or equal to 1. That means I'm going to keep the right side of it. So I'm going to erase everything to the left and just keeping everything to the right. There's my line. And I'm going to erase the other one. And for the parabola, x is less than 1. So I'm going to keep this left side. And I'm going to erase everything to the right side of it. Now it's time to check the end point. For the green one is equal to, so I do have a solid dot right there. But for the parabola is actually less than 1, so I don't have a point. It's going to be an open circle right there. Domain, everything to the left, everything to the right, so negative infinity to positive infinity. As for the range, the lowest point is actually at a 3, so I do have 3 all the way up to infinity. Yes, it is a function of negative 2. That's going to use the second one, so negative 2 squared plus 3, that's going to be a 7. 6, that's going to use the first one. 2 times 6 plus 1 is a 13. 1, the equal sign is actually on the top one, so I'm going to use the first equation. 2 times 1 plus 1, which is 3. And that is example 1. Example 2, x plus 5. At first, we need the end point, which is negative 2. So let's draw a line at x equals negative 2. Now we can graph the first line, x plus 5. So it's 1 over 1 as the slope. 1, 2, 3, 4, 5. That's my point. Trace back some, trace some more points so that we can connect the line. There's my line. And next one is x squared plus 2x plus 3. This is not in vertex form, but if you remember, we can actually use this to find our vertex, which is negative b over 2a, and that is going to be negative. My b is 2 over 2a, 2 times 1, that's going to be negative 1. And if I plug in negative 1, I would be able to find my vertex is negative 1. The negative 1 squared is 1 minus 2, which is negative 1 plus 3 is a 2. So that is my actual vertex, negative 1, 2. Then 1 left, 1 up, 1 right, 1 up, 2 left, 4 up, and 2 right, 4 up. There is my parabola. And now it's time to check which part we are going to keep. For the linear one, x is less than negative 2, so I'm not going to keep a solid point. That is going to be an open circle. Next, x squared plus 2x plus 3 is actually this portion to the right of the line. And I'm going to keep all of that. And I forgot to erase the other one. That needs to be erased. And this needs to be erased as well. And that does have an equal sign, so we need to include the point for the second line. Now, as you can see, this little point is kind of a bit special. It looks like this. An open circle outside with a circle inside. That means we do actually keep that point because that point is actually being colored, but it's not being colored twice. So domain, negative infinity to positive infinity. Range, my lowest point is at negative infinity, and my highest keep on going to infinity. Function, yes, of 3. I'm going to plug in the second one, so 3 squared plus 2 times 3 plus 3. That is going to be 9 plus 6, which is 15 plus 3, that is 18. And f of negative 4, I'm going to plug into the first one. Negative 4 plus 5 is a positive 1. F of negative 2, the negative 2 is included in the second equation because that doesn't have an equal sign. So negative 2 squared plus 2 times negative 2 plus 3, that is going to be plus 3. That's example 2. Next, example 3. Let's look at the endpoint first. If you look at the domain, this time we have two different endpoints. One is a 0, the other is at a 5. So this is my first line right here, and this is my second line. Let's grab the first one. First one is kind of simple because all that's happening is there's a -1 on the end. So that means this diagonal graph, I'm moving it down by 1. So vertex is right here, 1 left, 1 up, 1 right, 1 up, 2 left, 4 up, and 2 right, 4 up. There's my first equation graph. Next, the second one, 2 over 1x, negative 1 is the y-intercept, 2 up, 1 over, 2 up, 1 over, 2 up, 1 over, and 2 up, 1 over. So that is going to give me a line right here, and it actually looks like it's actually crossing the parabola. Next, 3. Well, that is the easiest. It's just a flat line right here. Now it's time to decide which part we are going to keep and which part we are going to erase. For the first line, x squared minus 1, less than or equal to 0, so I'm going to keep the left side of 0. So this part is going to be kept. Erase the rest. Next, oh, and doesn't have an equal sign, so I'm going to put a solid dot right there. 2x minus 1, starting from 0, so 2x minus 1 is right here between 0 and 5, so I'm going to keep everything around here, but I'm going to erase that part. And even though 0 is not included in this one, it is included in the other one, so we can still connect them. And lastly, we have a 3. That is going to be a flat line starting from a 5. So right here, this line is also, so that is going to be x is greater than 5. As for the domain, well, goes on forever on the left, goes on forever on the right. So negative infinity to positive infinity. And the range, well, the lowest point on this is -1, and the highest point on this, we actually don't know because that also goes on, well, that actually doesn't go on forever, but the left side goes on forever, so goes to infinity. Next, function. It is a function because this point is a solid, the bottom is actually an open circle. F of -2, I'm going to plug into the first one, -2 squared minus 1 is going to be a 3. F of 0, 0 is actually included in the domain for the first equation, so it's got to be 0 squared minus 1, which is -1. 5 is actually included in the second equation. It's 2 times 5 minus 1 is going to be a 9. And that is example 3. Last one, example 4. Let's first start with the endpoints. We have endpoints at -2 and endpoint at 1. -2 and 1. Now the first one, x is less than or equal to -2. So that is going to be, well, 2 over 1 as the slope, and -3 is the y-intercept. -3, 2 over 1 up. I'm going to connect everything. And then the second one, well, this is a little bit tricky, so let's have a look. We write the format of transformation again, a in the front, x minus h squared plus k. So that means my vertex is going to be the opposite of h, which, well, the opposite of number in there, that's our h. It's going to be -1 and -1. So that is the vertex. Next, we can use this thing and think it as a transformation. So because the vertex basically took care of the up and downs, all we need is a 1/2. To deal with is the 1/2 in the front and the negative sign. The negative sign flips everything upside down. But the 1/2, because it's actually after we have done the slope, I mean the square. So this is going to be facing down, and since 1/2, so 1 left, 1/2 down, 1 right, 1/2 down, 2 left, 2 down, and 2 right, 2 down. So that is going to be what it looks like. So now the left side is gone because I can start checking my endpoints. For the first one, 2x minus 3, I'm going to need to keep everything that is less than or equal to -2, so everything to the right left. And that is going down. It does have an equal sign, so solid point. Next, the blue part is going to be from -2 to 1, -2 right here to 1 right here. And I'm going to next deal with the very last one, which is actually at 1. I forgot to graph that one, so let's graph that one. Is at 1, and this x is greater than 1, so I'm going to keep everything starting from this point to the right. Now everything is graphed. Now let's look at the domain. If you look at the domain here, you may have noticed everything less than or equal to -2 is covered. Starting from -2 to 1 is covered, but 1 is not covered, and 1 going up is also covered. So it's going to be -infinity to 1, and then 1 to infinity. Next is going to be the range. The range is going to be a bit messy. First, -infinity to this right here, negative, what is that, -2. And well, actually at -2, everything is covered, even though I have a solid dot here. Well, even though I have an open circle on the top, I still have a solid dot on here. But we're dealing with range, so this is not -2, -1, 2, 3, 4, 5, 6, -7. There we go. And then starting from -7 going up, the lowest point I'm about to hit is at -3. But -3 is not included, so it's going to be from -3 to -1. The -1 is right here on the top of the blue. Lastly, the purple. The purple is exactly at 1, so they actually fit in quite nicely. Is it a function or not? It is a function. F of -6 is going to be using the first equation, so 2 times -4 minus 3, so 2 times -4 minus 3 is going to be -11. F of 2 is in the last equation, so 1. And f of 3 is also in the last equation, or in other words, inequality. That is also going to be 1. That is example 4, and that is everything for 4.19b. Thank you.